CDR, what happens is we call this an RFA, a request for action.
CDR is where teams come together and present their more in-depth design of whatever mechanism or piece of the robot they are assigned.
We have a shooter, which also doubles as an intake. We have a climber slash scaler, whatever you want to call it. And we have a breacher arm that goes through the obstacles.
The mechanism assigned to Mech Team 1 has been the boulder intake and shooter. It's a flywheel type mechanism where it uses two wheels like a football thrower or a baseball thrower to intake and shoot the ball in two motions but one mechanism, and be able to shoot for the high goal and low goal utilizing a motorized pivot.
We are the scaler team, and we are working with the tape measure to actually do our scaling. So we have a gearbox with 6 gears and a worm gear which helps us when the power is turned off. We're going to use a reel and reel out the tape with a hook on the end. Then the hook will rotate the tape down so that the hook is above the bar. Then when we reverse reel the tape back in, it'll catch on the bar and lift us up.
My mech team's working on the breacher arm right now. The breacher arm, in a way, was a sort of key for all the other obstacles that our robot couldn't drive over. So anything that involves opening a door, opening a gate, that's us, it's our job. Even to the cheval de frise, that's also our job.
Designs have gone from the conceptual level of let's just pick this up, let's move this around, and they have gotten to the point of we're going to take up this much space, this much weight. This is the risk involved in building this system. This is how much time it's going to take us to build this. And that way we can get that from every single team and figure out how this robot's going to look, how much time it's going to take to build, and what risks are involved in doing it.
I think it went well. It was very stressful because this year we had a lot shorter allotment of time to actually come up with the designs and make the presentations, but I think we got all of our ideas across, and I think everyone liked it.
I'm Sam. This is my 4th year on the team. I'm a senior. My job this year is hardware captain, and I work to integrate all the different pieces of the robot together to make sure that when we go, we're fitting everything within the space they need, nothing runs into other things, and all of the mechanisms are able to work together. Working with space allocations has definitely been my primary task. This robot that we're going to build has more independent mechanisms than any robot we've ever built before. We're trying to pack a lot of unique functionalities onto our robot. It involves a process of working, starting with basic, this is the box you fit in. Then you move into, how do you want to move? And then finally, does everything, if it has to move at all at the same time, can it all move within the same space? And throughout this process, you're in constant communication with the mech teams, because each team, obviously, as their design progresses, is going to start including different aspects, changing their motion slightly, changing, how fast they move slightly. So every single little change has to be communicated to all the mech teams, because the littlest change can cause everyone to have to move around, and there's been a lot of those. So it's been a task, but so far we've been able to keep it under check pretty well using CAD, so you can more accurately represent motions and more accurately represent how individual parts interact with each other.
Hi, I'm Jeffrey, and I'm a senior, 4th year on the team, and I'm the integration captain. The integration captain looks between all the teams to make sure they're communicating with each other, and also looks to organize the schedule. Over the last week, I've been working with Gabe and Sam to make sure all the teams are communicating with each other, to make sure their designs get passed down, so people like control systems know what to put on, and people like electrical know what to wire.
CDR overall went really well. I was really impressed with all the ideas that the teams brought based on how complex some of their mechanisms were. We had never really tried something on the order of a tape measure climber, but Climb Team was able to make that sound feasible, and 2 more weeks into the build season, we're finding that their CDR provided them a really good jumping off point, as did each team, to be able to go forward in designing these mechanisms.
Blizzard conditions possible around Baltimore, D.C.
Of heavy snow and wind causing havoc on the roads.
We see this as a major storm.
Declaring a state of emergency in Maryland.
So this is going to continue through Saturday all the way into Sunday morning.
Day 2 of an unforgiving storm pummeling Maryland is one for the books.
So we had midterms, and for Howard County, we aren't allowed to meet after, on midterm days.
Right after midterms, we're all excited, yeah, dude, awesome, we can finally get together. And then no, we had Snow My God 2.0.
Senor Snowzilla.
Snowmageddon.
The blizzard that rocked the East Coast.
Oh, the snow week. Oh, that was interesting.
Snow.
There was about, 2 or 3 feet of snow? A large amount of snow. We actually got off of school for an entire week.
That's another week gone, so we're down to a 4-week build season.
It was a rather hectic week. I haven't had any robotic season like that where we've lost an entire week like that due to snow. I know we lose snow days, it's not an entire week like that.
We were all stuck at home. Literally, no one was plowed out for a good 4 days.
But luckily we were able to meet via a lot of online sources. We set up a bunch of teleconferences, hashed out some of the spacing issues that we had after CDR, a lot of the weight and timeline and materials, and we ordered a lot of stuff because it was going to take us time anyway.
We began taking daily phone conferences with each other, trying with us and the mentors, trying to figure out what we're planning on still.
We also utilized a Facebook chat where a lot of information was passed back and forth between the team leads.
Every single day for over 2 hours, all the leads and mentors got on calls, and we were doing a ton of catting and a lot of sub-team calls. And then once people started getting plowed out, we were able to go meet at other locations.
We were able to meet off-site at a place called STEMaction, thank you guys. And there we were able to have a full field that we could at least conceptualize some of the obstacles. We were able to bring some computers and get our programmers programming. We finished a lot of the space allocations, came up with even more questions, but that's how build season works. So we got a lot done. That was where we actually first shot our ball.
Fire the holes!
We had students who brought the sockets box, which is a little electrical box where they can attach motors onto and just run it through a wall outlet. That's how we tested. We could get the shooter to shoot from point A to B.
Over the weekend after Snowmageddon, we came together and worked on putting a prototype shooter with our drive base. It's not fully to spec the way we designed it, but it's good enough.
We did extensive testing with the drive base that the drivetrain team provided us. We ended up taking off the middle set of wheels, and we found out that actually made it climb smoother over the terrain obstacles. We're doing preliminary tests on driving with a camera without being able to see the robot. Because of visibility issues, we'll have a competition with the portcullis and drawbridge placement on the field.
So that was a really helpful Saturday, and then from there we're trying to get all of our robot fully designed. We just had an entire scheduling conversation this past week, and we have decided this is how we're going to complete the build season. Of course, we're going to have obstacles, but that's what we built some extra time for.
Midterm, we expected the snow. That was a rather unpleasant surprise, but considering the fact that we nearly lost 2 weeks and we're still making this progress, shows that this team is actually a really dedicated team.
Lost time is not an excuse for not delivering what you need to be delivering.
Obviously the snow, we have a setback because of the snow, but I don't believe that it's going to be a huge problem because we're adding more days to how often we're meeting, and we are working a ton harder with a lot more strict deadlines so that we know we're going to get things done. I think the pressure's on, and although pressure is not always good, I think in this case we're going to be able to get it done.
With all this lost time, I just see it as a time to say challenge accepted, let's do this. I've always wanted to do a robot in 3 days, but I guess 4 weeks will work.